Here is a question under vectors. Vectors in 2 dimensions. Given the vectors with position, given the points A with position vector 2i plus mj, the point B with position vector 4i plus 4j, and the point C with position vector negative 5i plus 2j. Find A, the vectors AB and BC, B, the value of the constant m if the vector AB is perpendicular to the vector BC. Let's look at the solution. Okay, let's start again by collecting our position vectors. The point A has position vector 2i plus mj. The point B has position vector 4i plus 4j. The point C has position vector negative 5i plus 2j. Now, the first part, we're asked to find the vector AB and the vector BC. The vector AB will be the vector OB minus OA. Okay, remember, if a point A has position vector, then that position vector can be indicated as origin to the point A. This OA stands for the origin. Just like the point B, the vector is connecting the point B to the origin, and it will be OB. The point C, after plotting the point C, we'll now connect it with a straight line to the origin to obtain the vector OC. So whenever you see OB, you think of the vector 4i plus 4j. It's actually the position vector of the point B. If you see OA, you think of 2i plus mj. You see OC, you think of the vector negative 5i plus 2j. Now the vector AB, therefore, it is OB minus OA. Now let's put in the vectors. OB is 4i plus 4j minus OA is 2i plus mj. Now pay attention. If we fail to put this second parenthesis, we will not get the right solution. These second parentheses are very, very important in this expression. This first one, we might omit this first one. This first one is not very capital, but the second parenthesis is of utmost importance. We should not omit it. Look at the situation where someone omits it. Let's see the 2 different scenarios. Now this is OB, so let's just write OB. Then this minus. Look at someone who did not put the parenthesis. The person writes that. And then look at the person who writes the parenthesis. These 2 expressions can never be the same. Here, the negative sign is going to affect this member 2i and affect this member mj. But here, the negative sign is affecting only the member 2i. The member mj is not affected. But it was supposed to affect every member of OA. It's supposed to affect every member of OA. It's supposed to affect 2i and affect mj. Because the subtraction, we're subtracting all of OA. So when you say all in mathematics means you put them in parentheses. So we're subtracting all of OA. This is OA. All of OA. So that the negative will affect this member and affect that member. This is what we have done. So this one is wrong. This one is right. Don't make that error. So many students do commit such errors and they get the wrong solution. Now let's open the parentheses. Like I said, these first parentheses are not very important. So we can just write that as 4i plus 4j. Now open this parenthesis. Negative times that is negative 2i. Negative times that is negative mj. Now I go with I, j go with j. So we'll say 4i minus 2i is positive 2i. 4j minus mj. Since we don't know the value of m, we'll just say 4 minus m. All of them, they have the component j. So that will be the expression for the vector AB in terms of m. Now the vector BC, the same way we looked at AB, we took OB minus OA. We're going to do the same movement here. It will be OC minus OB. Now let's put in the vectors. OC is negative 5i plus 2j minus. Now here we must use parentheses to involve all the members of OB. The members of OB are 4i plus 4j. We must include all the members. This minus must affect all the members of OB. Now open the parentheses. We have negative 5i plus 2j, negative 4i, negative 4j. Once more, I go with I, j go with j. So we got negative 5i minus 4i gives us negative 9i. 2j minus 4j gives us negative 2j. This is the expression for the vector BC. That gives us the expression for the vector BC. So that does it for the first part, question A. Now, question B says, we should find the value of the constant m for which the vector AB, remember this is AB, so let's write it somewhere because we want to take off. Vector AB is 2i plus 4 minus mj. The vector BC is negative 9i minus 2j. Okay, so they say find the value of the constant m for which the vector AB is perpendicular to the vector BC. Now, question B. We are told that the vector AB is perpendicular to the vector BC. Okay. When do we say two vectors are perpendicular? We have to exploit that property. Two vectors are perpendicular if and only if their dot product is 0. So if we say the vector AB is perpendicular to the vector BC, it must mean that the dot product of AB and BC must be 0. So finally, this is the equation we have to solve. Now let's put in AB and BC and see how we can solve for the value of the constant m. Now that means what? We found AB to be 2i plus 4 minus mj dot BC, we found it to be negative 9i minus 2j. This dot product must be 0. All right. With dot product, we need to understand the following. I dot I is 1. J dot j is 1. But when the components are different, I dot j will always have 0. It's the same thing as j dot I will be 0. So when we remember this, we will now be able to facilitate our work. There's no need taking any I dot j component nor taking any j dot I components. So we'll just say I go with I and j go with j. That's all, because I dot I is 1, j dot j is 1. Any mixture will just give us 0. So we'll say 2i dot negative 9i plus 4 minus mj dot negative 2j. We expect that result to be 0. Okay? We expect that result to be 0. Now, remember I dot I is 1. So we'll just simply say 2 times negative 9, which is negative 18. J dot j is also 1. So we'll just go ahead and multiply 4 minus m into negative 2. So we'll say 4 minus m into negative 2. We expect the result to be 0. So we'll open this parenthesis with respect to negative 2. You have negative 18. Negative 2 times 4 is negative 8. Negative 2 times negative m. Negative times negative is positive. 2 times m gives us 2m. All of that equals 0. Negative 18 minus 8 is negative 26. All right. So if we take this negative 26 from the left hand side to the right hand side, it becomes positive 26. So we're going to have 2m is equal to 26. Remember, we're looking for m, so we have to remove this 2. The only way to remove it is by dividing both sides by 2. So that we see the 2 has gone. 2 here, 1, 2 there, 13. Therefore, the value of m for which the vector AB is perpendicular to the vector BC must be 13.